Well, good morning to all the viewers and my dear students. Now, as I told you in the last discussions about the phenomena called as polarization. So, I explain you with a certain convincing videos this process of polarizations. So, let me brief you about this process of polarization. As you know that the light, it is transfer in nature. The evidence that the light is transfer in nature, it is obtained only by this process. Earlier, the scientists thought that the light waves are longitudinal like the sound waves. As the sound waves undergoes diffraction, interference, so even the light wave also undergoes diffraction, interference, and whereas by this process of polarization, so one can able to analyze, assess that the light is, it is transfer in nature, it is not longitudinal in nature. Now, experiment has been conducted. One of the interesting phenomena which gives the evidence that light is transfer in nature, it is obtained by this process called as polarization. Now, what we mean by polarizations and what are the effects, all that was explained last time. Now, here is a simple experiment to show that the light is transfer in nature. So, that is, even if you can recollect the last time, I have demonstrated physically this effect. That is, once again, light. When we talk about light, I told you this light is obtained due to the acceleration of the electrons. That is, the electrons emits energy in the form of lights, and these accelerated electrons, it vibrates in all the directions. So, here a highly charged particle, according to Maxwell theory, it is produces a wave called as electromagnetic in nature. So, that is, the light is considered as electromagnetic in nature. So, here the light consisting of many components. So, where the major two components, that is the electric and magnetic, they are perpendicular to each other. Suppose if you pass this light through a certain crystal called as tourmaline. So, the interesting effect, even have shown you last time also. If you take a tourmaline crystal and hold it in front of your eye, then you look at the light, then in certain direction you can see the entire light. If the same crystal, it is like almost glass, then inside that the vibration will take place, and as the vibration will take place, plus the light will come away it will try to propagate also. So within that crystal there is vibrations plus propagation. So this area we called as the plane of vibration, and as it comes away, so after the effect, so that we referred as the plane of polarization. In order to obtain this process, there are different processes are used. One is the polarization is obtained due to reflection. Another is the polarization is obtained due to refraction, and in refraction, so there is one more effect is called as the double refraction. Now the polarizations by reflections, it is explained last time also. I mean, just a brief explanation about this effect is, so this has been observed that whenever an unpolarized light, if it is falls on a crystal at a certain angle, now since it is a crystal, so what happens? So there is a possibility of reflection will take place, and there is a possibility of transmission. So here whenever the incident light strikes the transparent media at certain condition, this particular spot, it will act as an opaque media, it acts as a well polished media, so that the light will get reflected. Now again for this same light at certain conditions, so this will act as a transparent media, as a light will undergo what is called as refraction. So that is bending of the light. So this is the direction of the light. Now actually it has to pass through straight like this. Now since it is not passing through straight, it bends towards this imaginary line, which is called as the normal. So this phenomenon is called as refraction. Now here we noticed that whenever the light, that is the unpolarized light, if this falls on certain material, as it get reflected, the reflected light is almost polarized, and whereas the refracted light is almost a unpolarized, it will again consisting of the same components. So this reflected light, which is a polarized but is not completely polarized, we can call it as a partial polarized. So certain effects for this is so whenever the light falls on the roads, as it if the roads are smooth enough, the light will get reflected. The light what it is get reflected, it is a polarized light. So here this is one of the principle, by means of reflection one can able to get the polarized light. Again, if you go on increase the angle or decrease the angle, at certain angle the reflected light and the refracted light will be perpendicular to each other. That means it makes an angle of 90 degree. If this is 90 degree, so this angle is 90 degree, then the angle of incidence it is referred as a Fresnel angle. Now where so one can able to get the maximum polarized light for this angle. So in fact, if you can remember, so last time, so we have derived the relation for this Fresnel angle, so which is given by, that is Bestow's angle mu is equal to tan of the angle of polarization, and the law states that the refractive index of the media is equal to the tangent of the polarizing angle. So that is, as the incident ray at particular angle, at this angle, so a maximum polarization will takes place. Suppose you want to achieve the maximum polarization, and see that the incident light should be at this angle. Now there is one more phenomena by means of which we can obtain the polarization, that is, it is by what is called as refraction. So the refraction will take place whenever the light enters the transparent media. As the light enters into a transparent media, I mean, say for example, if the light is there in air, and as it enters into a glass, this is a glass in the media and this is the air, this is the incident ray. So now if you can compare this, the air is lighter compared to the glass, so this is called as a rarer media, light media, and the glass is heavier media, it is called as denser media. Whenever the light passes from a rarer media to a denser media, suppose if we can draw a imaginary line, and this is called as the normal, then the line, this light will not go in a straight line, since it is been obstructed by this glass, so it bends, it deviates. So this deviated light is called as refracted light. Don't get it confused, because this is the bending of light around the corner, we also call as diffraction. Now this is not diffraction, this is refraction, refracted light. So by means of this process, so one can able to get this polarization. So that is, let us imagine that we have a glasses, pile of glasses. So that is what you can do is you take a glass plate, one glass plate, and pile another glass plate, and pile one more glass plate, or likewise you can have any number of glass plates. There is no restriction as more is the number of glass plates, so one can able to achieve this. Just see this, and then you can see how best this process can be obtained. Now here is, so these are the three glass plates, this has been placed, there are three glass plates. Now we are allowing an unpolarized light to strike the glass, and this unpolarized light, it is having the components along the x-axis, y-axis, which is nothing but electromagnetic nature. As it strikes at certain angle, so what happen is there is a reflection will take place here. This is a reflection taking place, as some part of the light will bend here. So that is, so the refracted light will be again inciding on this second glass plate, and again the reflection will take place. Again this light, again it is incident, that is a refracted light incident on the third glass plate. So again the reflection will take place. So now what you can notice here is so by a series of interaction of the light, whatever the light coming out is a polarized light here. So these light, the reflected lights, are almost completely polarized. Suppose you can have more number of glass plates if they are piled up, so the polarization effect can be increased. But again what we noticed here is the the light which is been falling, that is which has been falling here, and the light which has been coming away. So that is the transmitted light. This is a transmitted light, and this light, they are almost in the same plane of vibration. So so by this method one can able to obtain the maximum polarization. So here let us come back to this. So there are 3 crystal has been means glass is a crystal, they are been piled up here. This is the unpolarized light. As it falls, it strike the glass in the first here, then the reflected will take place, and then refracted light. This refracted light again, it will act as an incident to this. Say this is glass number 1, this is glass number 2, say this is glass number 3. Again this will fall to this incident light, it will fall to this, that is the refracted light from the glass 1, it will act as an incident light to the glass 2, then this same phenomenon takes place. So this light will get reflected and this light will get refracted. So this refracted light again, it will strike the glass number 3 here. Now this refracted light from the glass number 2 act as an incident ray to the glass number 3. Then again what happen is reflections and refraction will take place. This is the refracted light and this is the refracted light, and this is, it comes away. So this is the emergent light. So so these lights we can able to collect it, so that is, it is completely polarized, and whatever the light it is coming away, the vibration of this, see this light and this light is almost parallel. So that means the vibration of the particles in the vibration of this particle, they are almost in same phase. So this light is referred as what is called as the plane polarized light. So by means of this, so one can able to obtain a complete polarized effect. So next one more effect to obtain the polarization, it is referred as double refraction method. Now what is this double refraction method? It is the property of a certain crystals, like especially calcite crystal or a quartz or tourmaline crystals. When you look at these crystals, they are almost like glasses, they resemble the glasses. If you can see an object through these, then the object will be split into 2. So this is the property, it is the nature of the crystal to split, that whatever we'll see, if you can see a single line, it splits into 2 lines. So this is the property. So that you can just see in this video. So it is a calcite crystal, so where a single line seen through, it seems to be 2 lines. So no, it is not playing. So see this, yeah, video. See, this is a crystal, as I told you, flaky glass, and look at that that letters, it splits. So you can see that. So this is the property of the crystals. It is nothing to do with the effect. Now see that. See, as you go on, change the rotation, orientation of the crystals, and the splitting will also advances. So here, see, it actually you can see a single line here. This is a single line. It through this it split into two lines. So let's come back to this. Now here is, so imagine this is the unpolarized light, as this so this is the unpolarized light. As the unpolarized light strikes the crystal here, it splits into two rays. One ray will go straight, and this is called as the ordinary ray. It is same as this, and one more ray, it will undergo what is called as refraction, then it comes away, and this is called as an extraordinary rays. So here, as I told you, this is the concept related with this calcite crystal. So where a single ray of light will split into two by the process called as refraction. If objects are seen, so these objects will be seen to be two objects. So this is how we can able to obtain the different process of polarizations. Now coming to almost the end of this. Now what are polarizers? Polarizers, they are the materials on which if the light strikes on this material, that light will undergo what is called as polarization. Those materials are called as polarizer. So here what actually I told you, as the light strikes the material, the light consisting of many components, and some of the components will be absorbed by the material, and it will allow only certain selective components. So these material which is having this property of absorbing the unwanted components of the light are called as polarizer. And this polarizer it will found lot of interesting applications in engineering as well as in medical also. Certain applications of polarizer is that is, especially one of the a familiar example I can give you is, that is, we all know that especially the accidents on the vehicles during the night times are more. The reason behind is, if the two vehicles on the road, if they are in opposite direction, if the light of one vehicle falls on the light of the other vehicle, however the drivers are perfect enough, they can't able to see the vehicles, nor they can able to judge the road. So that leads to the accidents. Now it is quite natural, because as the light, straight light, if it is falls on our eye, lot of glaze will take place. Now because of this glaze, so we can't able to assess the objects. So this will lead to the accidents. Even sometime, if you can know this, that especially when the hunters, those who go for hunting in the forest, if they wanted to catch the animals like rabbits, deer, etc., so they'll carry a hunting torch, and the torch, if the light of the torch is allowed to fall on the rabbits, and then for a moment the rabbit will not run, because he can't able to see the ways, so that he want to escape. It will stand almost, then these hunters will catch. In the same way, if the animals, if they allow their light to fall on us, so definitely we will also stand, we will not run. So this is what it happens. So during the night time, when the light of both the vehicles opposite to them falls, so definitely we can't able to see. In order to avoid that windshield, that is the front screen, that is the front glass of the vehicle, it is called as the wind screen. So you might have seen that. So whenever the accident has been taken place, you can see a small broken pieces of glass. In between that, these glasses will stick between one plastic layer is there. Yet that plastic layer, it is a polarizer. So in the vehicles, the wind screens of the vehicles, so it is been provided with this polarizer. As the light strikes the vehicles, so the what is called as the reflection will take place. The reflected light will doesn't come inside, it will be outside only, whereas the reflected light, so that is it undergo polarization. So again, it depends upon the quality of the polarizers are used. So as a result, we can able to see the vehicles, so we can able to prevent the accidents. So this is where these polarizers are used. Even sometime, even to cut the glaze, cut the intensity of the light, the windows of the vehicles are been covered with certain transparent blackish thin material, plastic, that will act as a polarizer. And this polarizer, it is also been used to view the three-dimensional pictures. So that is whenever you go to a cinema theater to watch the 3D films, so they will provide a goggle, and that goggle has got a screen, and those screens are polarizer screens. So by using this polarizer screens, so one can able to see the picture, otherwise you can't able to see. Even the screen of the monitor, even the screen of your mobile phones, and it has got a polarizer. So because of that, we can able to see the clarity, because as the light emitted from that LCD, so it is almost in all the directions. In order to reduce, to increase the effect, so they use polarizer there also. So this polarizers also been used in photography. Suppose you want to get a very good photography, filters are used, and these filters will unwanted light will be reduced. As a result, it will try to increase the photographic effect. Even in the CD players, that is what is called as polarized laser beams, now which has been used, and these laser beams which will act as polarizers. So again, these polarizers are also used in certain instruments like polarimeters. It is to examine the rocks, minerals, even clothes. Even the polarizers are also been used to eliminate the glaze in headlights or the motor vehicles. This is one of the interesting applications. Those who are doing a research going towards the polar region, so in order to navigate themselves, in order to move their ships or the boats, whatever, in order to navigate, so they usually they'll carry a magnetic compass, but the magnetic compass, it fails in the polar regions. So then it has become very difficult for them to very difficult for them to navigate themselves. So then what they do is, so they use the concept of polarizations, and they'll carry what is called as a solar compass. And this solar compass, where they whatever the sunlight it falls, it gets scattered, it will polarize. So by using this a solar compass, so they will try to navigate. So this is this is all about what we call as polarization. The possible questions, so usually asked in the examinations are explain the Young's double slit experiment. So you have to describe this phenomena. So that is, this is related with the interference effect. So that is, if we can recollect that interference of light, it is related to whenever two coherent source, if their light overlaps on each other, and there is a very interesting phenomena, either it could be a constructive interference or it could be a destructive interference, but there should be a two source of light whose wavelength frequency are almost the same, and such lights we call it as coherent source, coherent light. So I told you in earlier, in this world it is not possible to have two source which emits a same wavelength of light. It is not at all possible. I give you many examples also, if you can remember. So here Thomas Young, he has given out a very simple way by means of which so this interference can be obtained. What he did, if you can just recollect this experiment. So what he has done is, so there is a source of light. This is a light source. As the light source, it allows its radiations in all the directions. As it falls on the obstacle, so he has made a small slit in this obstacle. Then the light will try to encroach, it will undergo what is called as diffraction. Then further in front of this, he has placed a similar obstacle with two vertical slits. This is one slit, this is another slit. Then what happens, the same light as it strikes this vertical slit, say S1, and say vertical slit S2, so this slides diffraction takes place here, and the diffraction will takes place. So there is a overlapping of the waves will takes place. If you can place a screen, so on the screen, so you see there are fringy patterns. There is so bands, a dark and a bright bands are formed, and this will show the constructive interference and destructive. For a bright fringe, the bright band, it represents the constructive interference, and the dark represents the destructive interference. So this is what you have to describe. Next is, now you have to differentiate between what is interference and what is diffraction. Now again it is very interesting, that is, as told you, in case of interference, so you require two coherent source of light. When the radiations or the light from these two coherent source, if they try to overlap, the resultant is an interference. Whereas in case of diffraction, only one source of light is sufficient. But here is, in case of diffraction, again imagine a source of light which is emitting the light in all the directions. Suppose if it falls an obstacle, if this obstacle has got a small opening or a aperture, and this aperture either it could be a circular or it could be round or it could be a slit. If it is a circular aperture, then what happens? You get a circular fringes are obtained here. If it is a slit, a vertical slit, then what happens here is, if this is a vertical slit, as the light strikes this obstacle, then here there are these lights according to Huygens, he said that. So here there are what is called as the primary wavelets are formed. So that means as it strikes the obstacles, the energy of the light will be used by this, and from that is the primary wavelets, and further from the primary wavelet, so again it will give out what is called as the secondary wavefronts, that is the secondary waves are formed. So by this process, what we call as the diffraction will takes place. So this is one difference. And second is, in case of interference, whatever we get that fringe pattern, so it is equally placed on the dark and the bright bands or the fringes, whatever you call, it is equally placed. Whereas in this case, in case of diffraction, you have a central bright fringe. As you go toward this side, the intensity it goes on reduces. So you have a bright spot, then the intensity goes on reduces. So these are the difference you can see. Now state the Bristow's angle. This is Bristow's law. So as I told you, this is a very simple law. As the incident ray, if it is falls at certain angle, so what happen? So there is a, imagine this is a glass, if the incident light falls on this, so there are two possibilities. One is reflection will take place, and other is refraction will take place. If you can control this incident ray either this side or that side, right? So that is at certain angle, when these two reflected light and the refracted light, when they are perpendicular, that is 90 degree, then this is the maximum polarized light which has been obtained. So then that is what the law says is the refractive index of the media, it is directly proportional to the tan of the polarizing angle. Now next is define what is called as polarization. Now again, just as I told you, whatever the light we watch, now it is consisting of many components. Some will vibrate this, so it is a mixture like this, and this is obtained due to the acceleration of the electrons which emits energy. Each accelerated electrons will possess energy, that means it will give out energy, and this energy is in the form of electromagnetic waves and electromagnetic phase. So that is, so there is a electrical field in this direction, say if this is x, if this is y, and say this is z, and there is a magnetic field in this direction. So both of them are perpendicular to each other. Suppose in front of it, if you can place a vertical slit, then what happen? It will allow only this way, the way which is vibrating parallel to the slit, and it will not allow the other. Say for example, now it is allowing only the electric field to pass through, it is not allowing the magnetic field, so it will cut. So this process by means of which we can obtain a particular plane of vibration is called as polarization. I know, just now I told you it has got many interesting applications. Next is differentiate between Fresnel's and Fraunhofer diffraction. In fact, these effects, they are being related with diffraction, and this diffraction two types, one is Fresnel's and Fraunhofer. In case of Fresnel diffraction, the source of light which is falling on the obstacles are at a finite distance, and the screen where the image is also formed is at a finite distance. If this is the case, then we refer this is as Fresnel's. Whereas the light is coming far away, the object is at far away place, is at say infinity. If this light falls on the obstacle, then what happens? The light will pass through. Since this light is getting reflected, it is getting scattered from certain objects. So that means this scattered light, it contains the information, that means it will contain the size, shape of the objects. If we can able to collect these, then we can able to reproduce the picture from the object from which the light is coming. So here, if you place a screen, the screen should be at far away place, then the image has been formed. But the image which has been formed here, it almost resembles the object. So this is a Fraunhofer diffraction, and in fact, so these two phenomena have been also used in what we call as the optical instruments. Last time, if you can remember, if you have been really present, so this I brought an instrument, I have demonstrated, I have shown you these two instruments. The next is, what is meant by the resolving power of an optical instrument? Now again, the resolving power, it is the capability, the capacity of the optical instrument. Means here the optical instruments usually a microscope or a telescope. A microscope is an instrument which is used to see small things which we can't able to see with our naked eyes, whereas telescope is an instrument used to see the objects at far away. Say for example, if the objects are lying at a distance of 1 kilometer, 2 kilometer, and so on. Suppose we wanted to see the shapes and size of the stars, so we use telescopes. Suppose we want to see the bacteria, virus which we can't able to see, or any minute particle, then we see microscope. So here the resolving power, we mean the capacity or the capability of the instrument to show two closely lying objects clearly. Suppose now, see, I have drawn two lines. Now for you it is looks like a single line. Actually I have drawn two lines. If you can see through a microscope, if the microscope can show these two lines as two separate lines, can show with two separate lines, then that instrument has got more resolving power. I think it is very clear. Again, this resolving power, it also depends on the limits, certain limits. So that is there are objects which are lying very close. Even if you can see either through a microscope or through a telescope, you can't able to see them separately. So that is the instrument not able to resolve them as two separate objects. So that is what we call as the limit of resolutions. Go through. So I wish you best of luck for your exam. Thank you very much.